Well, there. We are back. Wish there was some way I could set this up so we didn't have to go through this every single time. But I've watched people train on this, and I think this is what we're stuck with. So, okay. Let's go through each one of these systems. Take a quick look at them. The first one, this first one we'll study as well, the integumentary system. Mostly the skin and its accessories. Yes, you can accessorize the skin. Now, as we go through these, one of the things you're going to notice is that some of these systems have very obvious functions, and many of them have less than obvious but still important functions. So we'll read what it says about each one. Here she is showing some skin. Is the external body covering, which is our number one immune defense, is that the skin acts as a barrier and keeps bad things out. And by bad things, I mean the usual suspects. The usual suspects, bad bacteria, viruses, virus-infected cells, parasites, those kind of things. The skin acts as a barrier to keep those things out. It covers and protects the deeper tissues. There's that word. It also, when exposed to sunlight, synthesizes vitamin D. And vitamin D is important for calcium absorption from the digestive system. And calcium, having proper calcium levels, is extremely important. I'm going to talk about that all semester long. And we'll see a couple places, primarily as a component of the mineral, hard mineral of bone, and in a very important role in nerve impulse conduction and muscle contraction. So we need vitamin D to absorb calcium from our digestive system. Can you think of a food that is enriched with vitamin D? What food is enriched in vitamin D? Think about that. All right, it houses cutaneous receptors. Cutaneous is another name for the skin region. Subcutaneous is the region underneath the skin. These sensory organs tell us about pain, pressure, vibration, temperature. It also has at least regular, skin. I'm trying to think of I don't want to be overly general. There are glands in a variety of places, and some of these glands in some places and not others, but these are things like regular sweat glands, oil glands associated with hair follicles, the glands that secrete stinky molecules in armpits, the wax in the ears. Skin does all of that. And skin's about just under 10% of body weight. So it's pretty significant. Then we get the skeletal system. Obviously, it protects and supports the body organs. So protection, the entire central nervous system. The central nervous system is the brain and spinal cord. The entire central nervous system is protected by bone. The cranium, the skull, and the spinal cord protect the vertebral column protects the spinal cord. What else does the skeletal system do? Well, it acts as a attachment point for muscles so that we can move. And in some bones, the flat bones, mostly flat bones of the body, include the pelvis, what we're going to know as the distal end, the nose end of the femur and the humerus in the upper arm, and the bones of the skull, shoulder blade, sternum, all have regions where blood cells are formed. So they're very important in blood cell formation. That's where they come from, at least after about 5 weeks. Bones store minerals. I just mentioned that the hard part, the mineral component of bone, involves calcium and phosphorus. calcium phosphate it's called. And so it acts as a reservoir or savings account, if you will, for calcium. The muscular system allows manipulation of the environment. So we can move things. There's that word, locomotion. Locomotion. It's a brand new dance now. Everybody's doing the locomotion. I bet you've heard of that song before, right? You want me to sing it for you? Everybody's No, I'm not going to sing. Facial expressions. The muscles of the face are attached to the skull bones and on one end and the skin on the other. If we were here in person, I would make funny faces. I'm not going to turn on the video right now because I'm wearing workout clothes. So, helps maintain posture. The posture is not always good, is it? Should be. And produces heat. When we get cold, no, we're right in the middle of the beginning of the heat apocalypse, what I call the annual Texas heat apocalypse. It's here. So it's hard to imagine being cold. But you get cold, you shiver, and that's the muscles producing heat for us. The nervous system. Here's the central nervous system right here, the brain and the spinal cord. When the nervous system that's out in the body is called the peripheral nervous system. It's all attached. They're all attached to each other, so there's not like a real where we demark one starts and one ends is sort of arbitrary. Peripheral system starts when the nerves either leave or enter the spinal cord. I saw a Facebook meme one time. It had almost this very picture on it. And it said, all the other systems of the body exist to sustain this one. I could not argue with that. The nervous system is, that's of course the center of thought, where our minds are, but it's also the fast-acting control system of the body. We have two main systems that act to control the body and maintain homeostasis. The nervous system is one of them. The nervous system is the quickest acting. It can, pretty soon here, people will be hitting baseballs on TV. That's a pretty good trick, a pretty good reaction to the outside environment. It also helps to maintain the internal environment by monitoring the situation inside the body and altering responses as necessary. The other control system of the body is the endocrine system. The endocrine system is the first chapter you off with in AMP2, and it's a series of glands scattered throughout the body that control the body through a series of chemical messengers known as hormones, whereas the nervous system communicates with parts of the body through electrical activity known as action potentials. The endocrine system acts by chemical messengers, and usually it acts a little bit slower, but also it can have longer lasting effects. For instance, the hormones that cause us each to go through puberty, permanent effect there. And here's where they all are. We have a couple in the head. We got the pituitary gland and the pineal gland. The thyroid gland is in the throat, the front part of the throat, otherwise known as the anterior part. The thymus is in the chest, involved in immunity. The pancreas. Oh, we got the adrenal glands. What does the prefix ad mean? Ad. What about the pancreas? What does the prefix pan mean? Hey, in pancreas, what does the word root creus mean? Well, let's just see, shall we? Ad, A-D, means above or on top of or next to. So adrenal, near the kidneys. And if you look at that picture, you see that they're just sort of on top of the kidneys there. Pan means widespread. Oh, you know what? Ad is not on your list. I just called up your list. Ab is, but not ad. Oh, there it is. To or toward. To or toward the kidneys. Adrenal. Add to or toward the renal, the kidney. Pan. Widespread. All or universal. Like this pandemic. For years, I talked about prefix in the context of a pandemic, where I'd say an epidemic is where something happens locally, like it started out as an epidemic in the Wuhan province in China, but now it's spread everywhere. Let's use the exact words here. All are universal. The virus is all around the world now, so we call it a pandemic. Crease means to secrete. And endocrine. Endo. What does the prefix endo mean? Surely you've gotten to your E's. Right? Endo, within. And so endocrine means to secrete within. Remember that for A and P, and you'll look extra smart. So endocrine, to secrete within, is a series of glands that secrete their hormones, their chemical messengers, within the gland. And the hormones get picked up by the blood and carried all around the body. Pancreas gets its name because it goes almost all the way across the abdominal cavity, so it takes up a lot of space down. Well, not really a lot of space, but it goes from one side to the other almost, and secretes a couple different things. And then the glands that are determine the biological sex are the ovaries for females and testes for males. The cardiovascular system. I've mentioned that several times already, so we know what it does. It involves the heart, the blood, and the blood vessels, which transport everything. Here's a news flash for you. The heart pumps blood. If only everything in life was that simple. Now, the lymphatic system. The lymphatic system doesn't get a lot of airtime, but it's really important. It's exceedingly important. The lymphatic system is a series of vessels that does a couple of things. It picks up fluid that leaks out of the blood vessels. The smallest blood vessels of the body, capillaries, are very leaky and leak plasma into the tissues. I'll talk to you about what we're going to call these liquids in various regions of the body, whether it's blood plasma, interstitial fluid, or whatnot. I'll talk to you about that at some point soon. But it picks up that leaked fluid and sends it through a series of lymph nodes, which are literally security checkpoints, before returning that leaked fluid back to the circulation. So not only does it pick up the leaked fluid, but then this fluid washes into the lymphatic system. And as it goes through the checkpoints known as lymph nodes, our immune system can check to see if any of those usual suspects are there. Parasites, bad bacteria, virus-infected cells. And then inside the body, there's another one, maybe the worst of all of them, the cancer cell. And it's the job of the immune system to find those cancer cells and kill it. I've heard it said that at any one time, there's at least one cancerous cell in everybody's body. I don't really like that thought. I also like the thought that it's my immune system's job to find it and kill it before it causes trouble. And along with the other usual suspects. That's the job of white blood cells. We'll talk about white blood cells in more detail in A&P 2. It's a very key component of the immune system. The respiratory system. That's its obvious function is to supply the body with oxygen and get rid of carbon dioxide and ventilate the lungs and atmosphere. But what's not so obvious and not listed here is the role that it plays in maintaining the relative acidity, the pH, of blood. Blood pH and blood pH homeostasis is of critical importance. It's a very narrow range of acceptable pHs. And if the blood becomes too acidic or too alkaline, bad things happen, and by bad things I mean to and including you know what. So maintaining blood pH balance is critical, and the respiratory system plays a huge role with that. So do the kidneys. I haven't got to that yet. The digestive system. I talked about that already, how it breaks down through catabolic reactions, breaks down food into smaller molecules so that we can absorb them. The indigested foodstuffs are eliminated as feces, and it consists of not only the digestive system, but also some accessories like the liver and the gallbladder and the pancreas, not listed on here. The urinary system involves a pair of kidneys, the ureters, which are a duct which carries urine to the urinary bladder, and where it's stored until it can be released through the urethra to the outside world. At least the ureters are supposed to conduct urine to the urinary bladder. My dearly beloved aunt right now has one of hers blocked with a kidney stone, and she is not enjoying that. It's very, very painful. And poor woman is 80 years old, and I hope she's going to be okay. So what else does the urinary system do? Obviously, it produces urine. I think we probably all know that. In its pursuit of producing urine, it also helps us with water balance, water homeostasis. Whereas if we're very well hydrated, we're going to produce a copious amount. What does that word copious mean? It means a lot. If we're very, very well hydrated, we're going to produce a lot of urine. It's going to be pretty dilute. But if on the opposite, if we're relatively dehydrated, we still got to get rid of some of that waste product, that urea. We're going to produce a much less of a very, very concentrated urine. So depending on the situation, the hydration status of the person, the urinary system does help with water balance. As I mentioned with the respiratory system, it's also involved in acid-base balance of the blood, maintaining blood pH homeostasis. And electrolytes, those are dissolved substances that have electrical charges on them, either positive or negative. And those are things like sodium, potassium, calcium, chlorine. The male reproductive system. The overall function is the production of offspring. The testes produce the sperm, and the male sex hormone, the most dangerous substance in the world, testosterone. And then there's a series of ducts and to deliver these. Oh, here we go. I'm just going to read this to be safe. To aid in the delivery of sperm to the female reproductive tract. The female reproductive system includes the ovaries, which produce the eggs. Now look at this here, uterine tube. I mentioned earlier that everything needs a name. I get that. Remember me saying everything needs a name. Let's pick one name and never change it. And you said, well, what's the matter with this guy? He's crazy. Well, you probably learned about the connection between the ovaries and the uterus being the fallopian tube. Fallopian tube, does that sound familiar? Well, now look, do you see fallopian tube on this diagram anywhere? No, you don't. Why? Because it says uterine tubes. Fallopian tube is named after somebody, and there's this push to take the names out of anatomical structures. And Fallope was an Italian physician who he was in northern Italy, in the Bologna region, if you happen to know where that is. And he was known as one of the early anatomists who described this connection between the ovaries and the uterus, and so the name became fallopian in his honor. And now they want to take him out and replace that with uterine. I don't like that one bit. Okay, so there's, and you don't like it either. Let me tell you why you don't like it. For one, you're going to have to sit here and listen to me gripe about it all semester long, especially in the lab. And then two, you get to learn the old name and the new name because most people still use fallopian tube. Most people out in the world still use both, still use the older terms because these have only started changing in the last maybe 2 years. And so the people out in the working world learn the older terms. So you get to learn both. And then maybe someday, if you're lucky, some of the ones that you learn are going to get changed. And then you'll hate that as I do. So I'm going to call them the fallopian tube. And if that's an answer on a lab question, you can write fallopian or uterine. You get credit for both of them. So there's a survey of the organ systems. So, well, that looks like a good place to stop for now. So let's do that. Au revoir.